Chapter 11. Tomorrow's Code. The most famous distributed digital currency of all time for so many people, Bitcoin, is solely about cash, or, as we are now starting to see, all about the person or persons who invented it. Yet, the Bitcoin invention is nothing to do with money. It's nothing to do with Bitcoin itself either. Actually, it's all about the network, the infrastructure that underlies the blockchain, the Bitcoin. The blockchain is a dispersed cryptographic ledger that is shared by all computers or nodes on the network, and that records and verifies every effective transaction. The blockchain also isn't just about money, and though they took pointers from the same concept, but not using the Bitcoin P2P network, several other developers have started using the protocol to achieve many different purposes. For starters, we've got Namecoin, used to manage distributed domain names. BitMessage, used for asynchronous communication. Twister, used for the same as BitMessage. Ethereum, which you now know about. Both of these, like every other P2P platform, rely on architectures that are decentralized for building and maintaining network applications, both run by the community for the community. As such, while these applications can open a whole new world of possibilities, they also pose a whole raft of social, legal, and technological challenges, such as those already posed by other P2P applications that are now being used, such as Tor, BitTorrent, and Freenet. However, the conventional P2P network has never seen any of the problems raised by blockchain applications before. The Bitcoin protocol is basically a lot more web than P2P has ever been before. There are at least two ways that decentralized applications based on blockchain are distinct from conventional P2P applications. All user data, including their personal data, is not stored on local computers of the user. Instead, this knowledge resides in the cloud, mainly in the sense that storage is performed on a centralized database, in this case, the blockchain, and this database is exchanged by all the users on the network. All this means is that the data is omnipresent. Users can access their data anytime and from whatever location they choose, irrespective of the computer they are using. All user data is open, meaning that all actions or transactions carried out by a user are registered on the blockchain and made available to everyone. The user's actual identity is anonymous. No one else can see that, and the content of the transaction can also be encrypted for protection. Blockchain systems do not run locally, they run globally. We are distributed across the blockchain and are run on the resources given by each network user. The clients must run locally on the computer of a user, but the applications themselves are still available, even when such machines are shut down, as long as there are adequate resources allocated to the applications. It is this, given its decentralized existence, that makes blockchain apps almost the same as a cloud-based service, rather than a conventional P2P application. That said, between the blockchain-based application and a conventional cloud computing application, there is another significant difference. The blockchain systems are autonomous and are entirely separate from any central network, any third-party broker, and any central regulatory framework. Blockchain software is run by a mixture of individual P2P clients, each contributing resources to their network. As well as the flexibility, there's more security and privacy in the blockchain network. Put clearly, there is no single checkpoint and no single point of failure. Despite of this, the blockchain enables the implementation of decentralized applications with a mix of cloud infrastructure elasticity and ubiquity and the transparency and privacy advantages of P2P technology. Given the open blockchain, users can have as many identities as they want, none of which need to contribute to their real-world identity. This means the applications based on blockchain will use encryption to resolve privacy concerns. The challenges. Ultimately, most of the problems that a decentralized application is likely to face are related to the availability of resources and the difficulties with managing and organizing these resources. Long-term stability is only possible when some form of incentive is offered to users to contribute to the network. The incentive must be enough to ensure that the correct amount of resources are available at all times. Where a decentralized application includes a credit system explicitly built for the app, such as BitTorrent, or where they assume the role of a cryptocurrency, such as Ethereum, Bitcoin, or Namecoin, the goal is so much easier to achieve. This goes to the degree that both of these networks can provide each consumer with additional economic incentives and/or practical incentives to contribute to the activity of that network. Nonetheless, the blockchain network raises some very critical legal issues, and those issues are just like those that conventional P2P networks present. Specifically, we are discussing about anonymity and the chance that it may promote illegal activity or other malicious actions. For decentralized networks in the past, these types of problems have been resolved by the establishment of collective or mutual responsibility for all users linked to the network. While it may be difficult to determine the degree of responsibility that each user should be responsible for, and to evaluate that degree of responsibility, there will still be different individuals. The main challenge here would be allocating duties to one or more network users. And what would happen if the user figure vanished, if the applications for P2P were beyond the decentralized authority? Who will be responsible for this? Who is it that is responsible? We may learn some lessons from earlier P2P applications as a way to respond to these problems, but there is no doubt that the blockchain-based applications pose some critical and very fresh legal issues, and these are of very different nature to the conventional P2P architecture. Ethereum, the distributed autonomous company, and the smart contract. Ethereum are very interesting examples, as it advocates and envisioned the implementation of self-enforcing smart contracts. Definitions of this will be financial exchange markets, joint investment funds, etc., alongside autonomous entities that are wholly independent of any legal or moral body. Ethereum is a contract validation and compliance mechanism focused on one of the most advanced networks using derivative cryptocurrencies. As stated earlier, the explanation for its complexity is the addition of an internal scripting language, which is Turing complete, and which can be used to encrypt advanced types of transactions directly to the blockchain. Ethereum is not similar to as many of the other distributed blockchain applications. It is more like a distributed operating system, a framework that allows software to be built on it with the goal of creating self-contracts and fully autonomous systems, all of which would run directly on the blockchain. But while that may be this system's most innovative aspect, it also has the potential to be a challenge. It is common knowledge that contracts are a basic engine of economic transactions and businesses. Ethereum enables DACs, distributed autonomous companies, or DAOs, distributed autonomous organizations, to be implemented by providing the framework which will validate the contracts. These are blockchain networks, all of which have their own sovereignty, and their money is raised from user fees for their services, allowing them to pay for the resources they need to operate the network, such as bandwidth and computing power. The DAO is an autonomous organization completely independent of any legal or moral body. It is developed and then distributed on the internet. Their developers no longer have a need or a necessity. They will need to communicate with their users, but are not reliant on these users. Apps running on the blockchain follow the smart contract. This technological self-framework is what regulates operations, and Ethereum has raised a whole lot of law enforcement and liability issues that have never been seen in the conventional P2P network. Indeed, if the DAO is independently run, if it is neither owned nor controlled by a single individual, who is then responsible for the organization's operation? Who is in charge of it? Who is responsible? And since a DAO holds jurisdiction over its properties, how are damages paid for in the case of torts? Can they not be seized? With cloud computing, corporate authority is still restricted in that major online players, such as Google, Amazon, or Facebook, must adhere to the basic law principles. Nobody can challenge the authority of code with Ethereum, and no legislation may revoke it. This places the problems that occur in the same vein as those that arose with autonomous agents, such as the evolutionary viruses in software, or smart robots that are autonomous in their own right. Although this is most definitely stuck firmly in sci-fi. For now, it may become a possibility in the future, rather than with the conventional P2P app. Although Ethereum and the other blockchain-based applications might well try to liberate us from the law of the greater online operators, we have to make sure that we do not substitute the law for the rule of code, those that are immediately governed and implemented by the code that underlies the platform and can only exist in the ether.